Greetings, I'm Chan Ho-Yin Ely from the Serving Program of FDE. Today, I'm so pleased to present my final year project to you. My topic is the challenges and opportunities of the integration of BIM, Internet of Things, and facility management. To begin with, let me talk about the background first. Currently, the BIM application in the facility management is not satisfied, and only 15% of the BIM users are trying to adopt BIM with FM. Meanwhile, the technology of IoT is still exploring their best application opportunity. Therefore, this research aims to study the synergy effect of their integration. For the objective, I want to investigate the integration principle behind, and I want to identify the challenges and opportunity faced in the integration, and I want to give some recommendation on the improvement and the promotion of the integration system. For the research methodology, I've conducted a case study of Shanghai Street Project. In this project, they developed their own system to integrate this element, the system called Centralized BIM FM Platform. Through studying this system architecture, I can figure out how to connect different sources of data and how to achieve the integration. I've conducted interview with two different experts from the IoT and BIM aspect to investigate the limitation and the benefit of the integration. Now, let's move on to the most juicy part of my presentation, the findings. For the benefit of the integration, it includes the function of providing centralized database of all static and dynamic data. Also, the integration can provide instant response on the corrective maintenance and achieve the conditional-based maintenance by the real-time monitoring. For the challenges, it includes the problem of lacking open data, lacking relevant standard, and the cooperation problem between different stakeholders. The biggest communication problem is between the IT and the AEC records. Now, let's move on to the system architecture of the centralized BIM FM platform. This architecture can be separated into two important parts, the 3D dashboard and the 2D dashboard. In the 3D dashboard, they use the software called Autodesk Forge to integrate the 3D model and the IoT signal. For the 2D dashboard, they use an asset management software, IBM Maximo, to integrate the IoT signal and the BFM data together. Finally, they developed their own API, application programming interface, to compile two different dashboards to complete the system. You can look at the figure, and the right-hand side, it shows the 3D dashboard of their system. Now, let's move on to the discussion part. I've made an integration framework to provide guidance for the one who want to develop their own system. This framework provides the procedures of processing different sources of data. The X column is the procedures of the data processing. There is 4 different layers. The data layer, which include the connection of the raw data. The information layer, which convert the raw data into some useful information form, and the analytic layer is a process of convert the data into the understandable form or doing the analytic processing. And finally, the tool layer, it convert the data into the form that can be combined together. And the source of data include the IoT data, the equipment data, and the BIM data as well. In conclusion, the API is the key and the most important part of the integration. In the challenges of lacking open data and lacking reference standard, which means that people have to spend a lot of effort to convert or extract, transfer, and query the data into a form that they can integrate together. If you want to develop your own system, the API part will be the most challenging and the time-consuming part. For the recommendation, more standards shall be published to provide guidance for the industry, and the government should have more adoption and then share their experience to the industry. And this is the end of my presentation. Thank you.